So I finally got a chance to go to This Museum Is Not Obsolete in Ramsgate. Run by Sam. Look mum, no computer. I gave Sam a couple things for the museum collection and he kindly gave me a couple things as well. This really cool GPO, General Post Office inspection lamp. We'll find something to do with this, but also one of these cool things, a Uniselector, which is used in old telephone exchanges and all sorts of other stuff. This one specifically is a miniature version. So you would have seen its big brother in my last video, switching this projection display. Well, this has got pretty much everything that had, just shrunk down. So what is it? It's an electromechanical switch. You've got all of these pins along here which go through and are connected to these contacts around here. And as you send a pulse to the relay, see it move in there, it moves the ratchet mechanism, which moves the wiper, which is connected to the common terminal, and selects one of these pins. Or of course it works the other way as a demultiplexer, sending one common input and switching it to one of these outputs. And just like its big brother, it's also got an interrupter circuit so it can switch itself on and off. So what should I do with it? It's not the most creative use, I think, but I really want to make a sequencer. In this video, we're going to be building it, and then I'm going to do a separate video. We're actually going to make some decent music with it, hopefully. Now, there's plenty of reasons why it's a bad idea to make a sequencer out of a Uniselector. First of all, I mean, it's bloody loud, so you can barely hear the music, okay? Number two, it switches between 12 outputs. Normally, you expect rhythms to be kind of in groups of 4. So you can do 3 groups of 4. So, I mean, number 3, why would you make it this big when you could do it with one of these? Let's lean into the quirks and we might even come out with something a bit unique. I found this old box ages ago and it's been hanging around for the perfect project, and I reckon it's going to be great for this. It was obviously used for storing some old slides of some type. I don't know what type, they're massive. So if you turn it this way, it props itself up quite nicely. That's going to be great. So this is my basic idea of what it's going to look like. May change as we go along. You can see that there's 2 rows here, and that corresponds to the top 2 rows of these pins. There's 6 on here, and there's actually 12 available on here, but just because of the size of the box, I can only fit 6 in. So, and I think overall it's going to be more musically useful that way. What we're going to do is wire the first 6 pins here to the jacks and pots here, and the next 6 to the same jacks and pots. So as far as the Uniselector is concerned, it's just going around in a sequence of 6. And then there'll be a relay which switches the common output from this bank to this bank. So you'll actually be able to expand it to 12 steps overall, and the common input will be normally connected to around 5 volts, so you can use this like a sequencer. But you can also plug something into that and use it like a multiplexer or a demultiplexer. It's going to be internally clockable via the interrupter pins on here, which you can adjust the speed of, and also externally clockable, and you can control the clock-in modes with this switch, which is going to be over here, which will also let you manually advance the steps one at a time, so you can dial in the pitches of these when you're using it like a sequencer, which is really useful because it's not quantized, of course. There's a 3rd row of contacts here, which we're going to use for some indicator lamps, also to control the clock output and the relay switching between the banks. This type of miniature Uniselector comes with a socket, which is cool because it's got nice solder terminals on the back. And you see this rectangle here, that's the Uniselector, which I'm going to mount this way. I was originally thinking of having it in the socket that way, hanging out from it, but it's going to be a bit of a pain in the arse to unplug it and stow it away somewhere every time you want to close the lid. And I think this way shows it off better, which is the whole point of this thing. And I think I've collected just about everything I need to build this. Lots of wire, some pots, some cool knobs for this one, something a bit different, a switchy switch, Meccano of course, and a transformer to bump up the 12 volt wall wart to the 50 volts that we're going to need to switch the relay. The step is to clean up this box and take these little slide holder bits out, which I'm going to save because I have a good plan for those. How to mount the Uniselector. It's going to be in its socket and forward in the case so it's visible. It's fairly hefty, so it's going to need a substantial mount, and I don't really want to see the mount. It would be cool if it just looked like it was just floating, so I've got to figure out a way to try and hide it. Okay, I built a pretty sturdy mounting bracket out of Meccano, and that will fix onto the box with 4 bolts through the bottom. So when it's there, considering there's going to be wires going down here, the mounting's going to be fairly invisible, which is great. Alright, painted that Meccano. I think it looks super cool. It's perfect colour really, pretty similar to all the GPO racks. Now what I've got to do is work out all the component spacings on this strip board and get it cut, and then we can start soldering stuff on. Here is the strip board, I painted it black as well, ready to go. Alright, it's looking good. We've got a load of pots on, a load of jacks on now, so I can start explaining a bit more about how this is all going to work. This bit here is representing our Uniselector. If you want to use it like a sequencer, you just send in a voltage to this common input and it switches sequentially through these outputs. Each of those outputs, they're all connected into a voltage divider, which is these pots here. Then all of those go through a diode which isolates them from each other and go to another voltage divider, this one here, which will turn up and down the overall level of all these pots. And then it comes out one jack right here. Additionally, these individual jacks here come directly off of the Uniselector pins, so you can use it just like a demultiplexer or a multiplexer. And you'll recognise all this if you've ever built a Baby 8 sequencer. But the cool thing with this is you don't have to have a fixed voltage input. You can put an LFO in, for example, or even audio. So you've got 6 steps here and you've got 6 steps down here. You can take the output of the 6s from these jacks, but you can expand it so you're getting 12 steps, and to do that we're using this relay here, and every time it reaches the end of this 6 it switches this output here to the beginning of these 6, and then back to this one and back to this one. Okay, so that was some fun switching, but this is going to be even better. Right, so this switch here is going to be what's controlling all of the clocking modes. So there's different ways that you can advance the steps in the sequencer. So when this is in the middle position, it's going to mean that the Uniselector relay is going to be controlled by an external input. So if you put 5 volts into the clock jack, that is going to advance the Uniselector. Then I want it so you can advance it manually. And the last function that the switch needs to do is when it's in the latching upwards position, that is when power is connected to the interrupter pins on the Uniselector and it's switching itself, the speed of which will be controllable by a pot on the panel. In addition, when you're using the manual advance and interrupter clock settings, I want there to be a clock output so that you can connect that as a gate into a envelope generator, for example. Now there's limited space on the panel, and seeing as you don't need the clock input when you need the clock output and vice versa, why not just make one clock jack and make it an input and an output, depending on what clock mode you're in. So I managed to figure out a way to do all of that just with one switch. This is a really cool switch. You can see here it was made by Telephone Manufacturing on license from Ericsson telephones. That's Sony Ericsson from the mobile phones, the people who made Decatrons. And it's great because one way it's momentary, the other way it latches, and it's got 4 poles, and all of them are double throw switches. And you'll see as you move it here, the contacts at the top switch, the ones at the bottom don't. That's very important to note. On the other side, it just mirrors it. And when you go down, the contacts on the bottom are switched, but the top ones are not. I actually have another one of these that has 8 poles available, but if I can, I'd rather use the one with the 4 poles missing and save this for another project. And if we start going through the switch positions, you can start to understand how it all works. Let's start with this middle position here, and you'll see that the top switches are connecting the top to the middle pin, and on the bottom, the middle pin is connected to the bottom. That's the same on both sides. So if you follow through, we can see what our circuit is going to be doing. The input jack here is connected down here, which is connected by a wire to the middle pin here, which is connected to the top, which is connected to another wire to the pin here, which is connected to the middle, which goes to the clock relay coil. So if we send a 5-volt pulse into here, it's going to go around here and into the relay coil, which switches on 50 volts to this relay and advances the Uniselector once. The reason we're using a relay here is so that we only have to send in 5 volts to our input jack, and it's going to switch on the 50 volts that the coil needs in the Uniselector. You'll see down here that the middle pin is connected to the bottom pin, which is connected to nothing. So this isn't doing anything, you don't have to worry about this. Now, if we switch it into the latching position, you can see that nothing happened in these top switches here, but the bottom has switched over. So now the middle pin is connected to the top, and you can see it's a pretty drastic change because now the clock output pulse is being connected to our jack. So the jack has become an output, and the clock output pulse is just a pulse that happens every time this Uniselector switches. So you can send that out to an envelope generator and then control a VCA or a filter with that. You'll also see that now the 50 volt output from our transformer is connected into the interrupter pin of the Uniselector. So the Uniselector is going to be advancing on its own, and the speed of that is going to be controllable with a pot. So the Uniselector is being internally clocked, and we're sending out the clock pulse every time it switches through the output jack. And this wire here is disconnected, so you're not going to get a pulse into the relay coil. Effectively, this is all out of the circuit. Now, the final position, this momentary position here, you'll see it doesn't affect the bottom switches, but the top switches have gone over, and now the middle pin is connected to the bottom pin on both sides. So when you push this down, 5 volts is now being connected to our output jack, and that's going to give us a nice output gate for your envelope generator. And also the relay coil is being connected to 5 volts, so it's going to advance the Uniselector one time. Now there's a little quirk with the Uniselector because it doesn't advance when the relay is turned on. It advances when the relay is turned off. You see here, turn it on, doesn't move, and I turn it off, it moves across. So when you send in a 5 volt pulse to here, it actually is going to switch when the pulse turns off, which is fine if you're just using this on its own, but if you want to also sync up other stuff, you're gonna have to invert that clock. So you'll also notice that when you're doing the manual advancing, the Uniselector is actually going to advance when you release the switch, not when you press it down. But it would be much better if it was the other way around. We can do that by making this clock relay turn the power off to the Uniselector instead of on when we send in a 5 volt pulse. Trouble with that is that then the relay is going to be on for extended periods of time, and it may heat it up and destroy it because it wasn't designed to be used like that. I'm going to recklessly try it. We'll see if it damages it. It can be switched back the other way really easily. Maybe it'd even be fun to be a bit quirky like that. Now, I do need to adapt this slightly because I don't have any 5 volt relays. I've only got 12 volts, but we want to be able to switch that relay with a 5 volt signal coming in from the clock jack. So how do we do that? I'm gonna fess up here, and I'm absolutely gonna cheat, and I'm gonna use a transistor to amplify the signal. This does also mean that we're gonna have some protection of our relay from overvoltage, and it does mean that it's gonna be switching much more reliably if you have a signal coming into the jack that's not quite 5 volts. Also, I've switched it round so that instead of sending a voltage into the positive side of the relay coil, we're actually just going to take the negative side to ground. This will give us some faster switching. This resistor here protects the base of the transistor from too much current, and this diode here, which is anti-parallel to the emitter and base, protects that transistor junction against a negative voltage coming in. Well, I've been busy. You'll notice some big changes. First of all this wiring. So now all of the pins on the Uniselector are wired to where they should be on the strip board. Back pins are all going to these lamps here, which are real miniature bulbs, and also connected to some of the relay switching. The second row of pins are connected to these 6 pots and jacks down here, and the first row connected to the top 6 pots and jacks. Now have power. Got a socket coming in and over to the strip board. We've also got all of the pins to the relay coil in the Uniselector connected, so we've got all of our clocking modes complete. Let me give you a demo of that. So you'll notice when I turn it on that the relay is going to turn on, and that primes this ready to switch to the next position. There you go. Now, if I do a manual advance, it turns the relay on the Uniselector off and advances 1 position. We've also got the 50 volts from our transformer going through this pot here and being connected to the interrupter pins. So we can turn that on by latching it upwards and control the speed with the pot here. That's about 24 volts there going to the interrupter pins, and if I turn the pot up, it takes it all the way to the full 50, which speeds it up. Now you can't switch much slower than that using the interrupter settings, but that speed there, the slowest speed, that's not so useful for a musical sequencer, so we want to be able to clock this Uniselector slower. When the switch is in the middle position, it allows you to plug in an LFO and clock it externally. So let's get some sound coming out of it. So now I've got the CV output of both banks plugged into the pitch CV of an oscillator, and you can see it's selected the first step here, and if I move this pot you can change the pitch and the overall pitch of the entire bank here with this end pot. If I advance it, every time the steps advance it's sending a clock pulse out of the clock jack, which you can use like a gate. So here I've got it hooked up to a VCA, and every time I advance, just for as long as I hold down the manual advance, you'll hear the note. And this relay here is responsible for sending out a clock pulse in the interrupter clock setting. This relay here is bumping up the 5 volt clock input to the 50 volts that's needed to advance the Uniselector. So I've tidied up all the cabling with this waxed twine here, and I've used a technique taken from the Bell telephone laboratories. This is how they used to do it. There was loads of different techniques. NASA had their own technique, but of course we're working with telephone equipment, so I figured the Bell system would be most appropriate. I've now cut out a piece of acrylic and started drilling the holes in for it. There are the 4 bolts that the Uniselector mount will be attached to. So we've done quite well, but we've got a weird problem that's just occurred. These 2 lamps are on when they shouldn't be. The diodes have failed. Oh, so yeah, that's a potentially big problem. I'm suspecting the back EMF from the relay coil has fried them. Which is odd because it does have a flyback diode on it. So I've replaced those diodes with 1N4007s, which means they have a breakdown voltage of 1000 volts now instead of the 100 volts of the 1N4 and 48s. So they should be a bit more sturdy. Here it is in the case, held in place with some Meccano brackets. I super glued some nuts on the back of them. Got the knobs on now. Looks pretty cool. Next step, doing some labels. It really is a lot quieter when you put the panel on. And then with the panel on, really mutes it. Hey! So I'm happy to say that it's finished. It looks pretty fucking awesome, I think. It's not bad. Should we turn it on? There you go. And I've got it set up at the moment so that you've got one sequence coming out of each of these and it's in harmony. Let's see. It's absolutely bonkers. Should we go through some of the functions? So you can manually advance the steps, press down, and we can make it advance automatically by sending in a 5-volt signal. There's also the last clock mode, which uses the interrupter pins on the Uniselector. And if I take a signal out to a VCO, you can control the pitch of that. So remember, we're only hearing from this jack the first 6 here. Even though the lights are going down, you're only hearing these 6 cycling over and over. And you can do the bottom 6. Then you can take the output of all 12 from this middle jack, and we can control the overall pitch of each row with the end knobs, and the voltage that's being sent into the common pin on each row of pins on the Uniselector can be adjusted by this little trim pot in here. So that will set the maximum range of all these knobs. You don't have to use it like a sequencer, you can just use it like a sequential switch. And the main way that I'm probably going to use that is to power switching displays like that projection display. But you can put audio and things through it as well. So it's going to be another video of me making some music with this thing. And if you want to see a bit more about this and other projects, there is Patreon. It would be really nice to be able to take one afternoon a week off work to do more stupid stuff like this. That's the aim. So the Patreon support is really valuable. Other projects I'm working on, things like this Disky display, an LED segment display, cipher machine module, and a whole series of Lunetta style Eurorack breakout modules. So there's going to be loads more coming. I just got to find the time. See you in the next one.